Hi, welcome to this video. My name is Revi, and I'm an economist and a premium private tutors in London. So this video, it's the first of a series on uncertainty. And today's video, I'm going to focus on uncertainty, what makes uncertainty in economics, and risk aversion. And the plan is that by the end of the video, you should understand what this utility, expected utility maximizer mean. And I want you to understand that it's an assumption. Um, And the second thing, I want to talk a little bit about what it means to be risk averse. So far in the previous videos, we were talking about everything that was certain. We had a certain amount of money, we know what the prices were, we were choosing between one good or the other. So in the X's so far, we had, for example, like food here or shelter here. Okay, we're going to switch gears and we're going to focus on a single good. And I think the best way to think about this is money. Okay, so think that here you have X, and with X, we're going to capture money. But now we're going to be in an uncertain world. Okay, so now let's say, for example, each square is capturing um, 1 unit of money. So let's say this is £2. Okay, and this is the utility you get from that. So utility of the £2 is equal to, in this case, 3. Okay, so here it's going to be the utility of getting money, but this is the utility of getting some money for sure. Okay, so if you give me £2, this dot here is telling me that the utility that I will get from those £2 is 3. Let's take another one. So let's make sure that here, let's say we have £5. So let's say £5, and the utility there is 5. Say 5 and 5. So utility of 5 is 5. And of course, those numbers are arbitrary. I didn't have any agenda or anything about those numbers. Okay. Now, what I would like to show you is imagine that I now tell you that either you're going to get £2 with 50%, or you're going to get £5 with 50%. So this is what you are getting. You might want to think about this as a lottery. So one way to visualize this is to say, here's a lottery, one, and I'm either going to get £2 or I'm going to get £5, and the probability here is 50%, and the probability here is 50%. Okay, and the question is, what is the utility that I'm going to get from this lottery, okay, or this uncertain pairs of outcome? And the answer to this is we're going to make use of an assumption. We're going to say that people in this world, and this assumption is going to hold throughout most microeconomics courses, or I might even say all microeconomics courses, we're going to assume that you care about expected utility. In other words, you will be able to say, well, the utility of 2 was 3, and the utility of 5 was 5. And because this is happening with 50%, um, and this is happening with 50%, I'm going to do simply a simple average of those two, or a weighted average if you like. So it's going to be 3 plus 5 divided by 2. This is a simple average. The weighted average would be the same because you'll have the weight 0.5 times 3 plus 0.5 times 5, and we'll come up to 4. Okay, so I already know that if you give me 50% and 50%, okay, the thing that I'm looking for is right here in the middle. And this bit here is going to be my expected utility. Okay, and that will capture how much benefit I get from that lottery. It's an assumption. So first thing first, whenever we're dealing with uncertain situations where the outcome of money is uncertain, we're going to rely on the expected utility maximizer assumption. We're going to assume that this person is an expected utility maximizer, right? So for example, if I give you a different lottery, let's say, for example, I give you a different lottery, and in this case, let's say that you get 1, okay? And it turns out that your utility is also 1. So you get less money. Utility of 1 is also 1. And now I give you more money. Let's say I give you 6, and that is 7. 6 and 7. Let me do it with different colors so you can see it's a different lottery. Okay, so now I have lottery 2 in different color, and it either gives me £1 or it gives me £6. Okay, and the question is, which lottery would you prefer? Right? Well, let's assume that it's still 50-50. It didn't have to be. But let's assume that it still is 50-50. Well, in that case, the assumption of expected utility maximizer would tell us that here the utility of 6 is also 6. We would do the expected utility of the purple lottery, or lottery 2, is simply going to be equal to simple average. 1 plus 6 divided by 2 is 3.5. And just having those 2 points, the expected utility maximizer assumption is going to allow us to say that this individual will prefer lottery 2 to lottery 1. Okay, that's the first thing. The second thing that I want to cover in this video is the definition of a risk-averse individual. And here's what I get every time I tutor someone who might have already started or already finished their microeconomics and maybe they're preparing for an exam. Almost always, when I ask someone, what is a risk-averse individual? Their instinctive answer, which is very incorrect, is someone who does not like risk. Okay, that is a very, very vague and very incorrect definition. But let's actually think about why that is incorrect. So, risk averse. Well, someone, so this is incorrect, so we'll do a little bit of a, caution. Someone who dislikes risk. Okay. And my favorite example to make the point here is, imagine that you have one lottery that gives you, let's say, £5 for sure. And you have another lottery that is risky. Sometimes it gives you £25, and sometimes it gives you £6. Let's say maybe this happens with 80%. This happens with 20%. And I tell a student, imagine that you are extremely risk averse as you like it. You have a risky lottery and you have a safe bet. Which one would you prefer? Okay. Now, if you don't qualify this assumption, someone who dislikes risk, you could incorrectly say, well, this is risky, this is safe, and therefore I'll choose lottery 1. Okay. But most students actually realize that, hold on one second. Lottery 2 is risky, there is uncertainty in it, but even in the worst case scenario, I get 6, which is better than 5. So it cannot be that definition, someone who dislikes risk, is a very good definition, right? In fact, someone might prefer this lottery here, even if, for example, here they get a 4, for example, which is less than a 5. Okay, and we need to figure out a way how to define that. But if you're watching this video, a big majority of you, I'm sure, will immediately think risk averse, someone who dislikes risk. However, that's not quite the right definition. Let's try and understand a little bit, what does it mean for someone to be risk averse? Let me go back to this picture here. And let's focus on that first lottery. Okay. Now imagine that I go to that first lottery. So I get rid of this purple lottery just so that I don't overload the graph. Okay. Here we go. So we had this lottery here, which gave us an expected utility, we said, of 4. Okay. Now, imagine that I now give you a different lottery, a safe lottery. So the lottery 1 was either 2 or £5, 50%, 50%. The expected utility assumption allowed us to say that this was 4. And now imagine that now I give you a new lottery. But before I give you that new lottery, this new lottery, I'm not picking randomly that number. The number that I'm picking is the expected value that you're going to get. So if you get 2, 50% of the time, 5, 50% of the time, the expected value of that would be a simple average. So 5 plus 2, 7, divided by 2, 3.5. So now imagine that I now give you something for sure that gives you 3.5 pounds. Now, the problem is, I have not told you the full utility function of this individual. I just said when they get £2, they get utility of 3. When they get £5, they get utility of 5. So if I tell you what sort of utility will they get when you give them £3.5, your answer should be, I don't know. I don't know what the utility they will get. Okay. Well, risk-averse individuals, my favorite definition of risk-averse individual is to say that when faced with a lottery, a risk-averse individual would strictly prefer, right, or would or at least weakly prefer the expected value of the lottery rather than the lottery itself. And therefore, with that definition, I'm going to write that down. So a risk-averse individual prefers the expected value of any lottery or any uncertain outcome, if you like, to the lottery itself. In other words, what the definition of risk averse is telling you is that if you are getting a lottery and you know the expected value of the lottery, even if you don't know anything else about the shape of the utility function beyond the fact that it's risk averse, you'd be able to conclude that that individual would give up the lottery if you were to offer them 3.5 pounds as opposed to this 2 50% of the time or 5 50% of the time. This has implication. Let me give you two of my favorite implications. Okay, one, if you are a risk-averse individual, you will never go to a casino. Okay, because by definition, when you go to a casino, the expected value is negative. So let's say, for example, for every 100 pounds, maybe you lose a pound in a casino. Okay, so this individual, if he's risk averse, he would be better off giving you that pound that you're losing, right? Um, and not take part. Right? And of course, no one can force you to go to the casino. And therefore, the conclusion is that a risk-averse individual, as defined, will never go to a casino. Because when presented with the expected value of a lottery and the lottery, they would always take the expected value. Okay. And therefore, they'll never go to the casino. Here's another example, which will be a bit more applied to the tuition business. One of my students recently asked me, Revi, you have these tutors that work for you. Why don't they do it on their own? And one answer to this employer-employee relationship might be related to this idea of risk averseness, right? The tuition industry is not smooth. People tend to approach us during a busy season, for example, versus if you do freelance, you're going to get a lumpy income, okay, or uncertain income. And if you do it as an employee, you can get a smoother income. And therefore, if you're risk averse, you would prefer to get the smoother income, even if it means that on an expected value, you're getting a little bit less, okay? Because remember what this says. This says that, say, for example, the expected value, this was 3.5, you would prefer the 3.5, and therefore, you might even prefer something slightly less than 3.5, okay? That would still make you a risk averse. So, in summary, today we're starting the first video of a set of videos on uncertainty. And by the end of this video, you should realize what assumption is necessary to make progress on uncertainty. And finally, you have one definition of what it means to be risk-averse individual. I'll give you two more of those, and I'll see you on the next video. Thanks for listening.